In this question, we are given that the particle is moving in the elliptical orbit described by this equation, that is 2x squared plus 3y squared equals 50. And when the particle passes through the point negative 1 comma 4, its y coordinate is decreasing at the rate of 2 units per second. That is, I have written this as dy over dt equals negative 2 units per second because the y coordinate is decreasing. So we have to put a negative here. And in this situation, we have to determine at what rate the x coordinate is changing. That is, we have to determine dx over dt. So let's see how to determine this rate of change of the x coordinate. So here we will do the implicit differentiation of this equation. So I'm going to differentiate both sides with respect to time. That is d by dt of 2x squared plus 3y squared, and this equals differentiate the 50 with respect to time. And so this can be written as d by dt of each of the terms inside the bracket, that is 2x squared plus d by dt of 3y squared, and this equals differentiation of a constant is 0. So I put 0 here. Now let's differentiate this term with respect to time. Here we see that we have a constant 2 here, so we can just factor it out and then differentiate only the x squared with respect to time. And similarly, in the other term, we see this constant factor 3. So you can just take it out of the derivative. So we get 3 times of d by dt of y squared, and this equals 0. So let's differentiate this x squared. And here we should use the power rule to differentiate the x squared. That is, differentiation of x squared is using the power rule, it is 2x. And then using the chain rule, we should differentiate x with respect to time. So differentiation of x with respect to time is dx over dt plus, we have this 3 in front. Now differentiate y squared with respect to time. We should use the power rule first. So we will get 2y, and then differentiate y with respect to time. This is according to the chain rule. So we will get dy over dt, and this equals 0. Observe that we have the common factor 2 in all the terms. So we can simply cancel this 2 as well as this 2. It's mathematically equivalent to dividing by each term by 2, and 0 by 2 also gives 0. So let's rewrite this equation. So we have 2x times of dx over dt, and plus we have 3y times of dy over dt, and this equals 0. Now let's plug in the values which we know, that is dy by dt equals minus 2, and we also know the x and y values, that is from the point we know that x equal to negative 1 and y equal to 4. So plug in x equal to negative 1 and y equal to 4, and also dy by dt equals negative 2 into this equation. And then we have to solve for this dx over dt. So let's do that. So this becomes 2 times of x is negative 1. We put dx over dt. We have to solve for dx over dt, plus 3 times of y is 4, and dy by dt is negative 2, and this equals 0. And so this gives 2 times negative 1 is negative 2 times of dx over dt, and this is 3 times 4 is 12, and 12 times negative 2 is negative 24, and this equals 0. Now let's add 24 to both sides. So we get negative 2 times of dx over dt, and this equals positive 24. We divide by negative 2, so we get dx over dt, and this equals 24 divided by negative 2, and this equals negative 12. And so this is the value for dx over dt. Otherwise, we say that the x coordinate is changing at the rate of 12 units per second. This is units per second. or we can say that x coordinate is decreasing. X coordinate is decreasing at the rate of 12 units per second.